Now we will compare the differences between alpha, beta, and gamma decay. To show this, we're going to use uranium-235 for each example as our parent element. Notice that we write our arrow. Our arrow means that a reaction has taken place, and our radiation notation is going to be after that, either alpha, beta, and gamma. Now we're going to focus on the mass number of our parent element and our radiation that's emitted. Notice how that I'm highlighting all of my top numbers, and I'm expecting to put 1 in that last space. Also notice that I'm showing that 2 elements are separated by a plus sign. A plus sign in chemistry means something different than it does in math. A plus sign in chemistry means that it's showing separation of 2 things. Now, moving across the top, if I had 235 particles in my nucleus to begin with, and I had 235 to begin with, I emitted 4 of them out of that nucleus, how many do I have left? If you said 231, you would be correct. We're going to follow that same example for beta decay. If I had 235 particles in my nucleus, and in beta decay, none of those are emitted, then I still have 235 particles in my nucleus. And the same for gamma decay. Gamma and beta are alike in that the mass number doesn't change. Now let's look at our atomic numbers. I've highlighted these in blue. The mass number is highlighted in yellow, and the atomic numbers are highlighted in blue. Looking at example 1 for alpha decay, we see that we started out with 92 protons. But in the process, we've lost 2. In alpha decay, 2 protons were emitted from the nucleus. So my daughter element should only have 90 protons in the nucleus. In beta decay, what's emitted is something similar to an electron. And this is very different than what we've seen in alpha decay. In beta decay, you have to notice that we have a negative charge. Let's reference what we've written in green for alpha decay, just to make sure we understand before we begin this next step. In alpha decay, I began with 92 protons, I lost 2, and now I have 90 protons left. When I write that same process for beta decay, I began with 92, and then I lost a -1 charge. So when I write that formula out, I'm subtracting a negative number. And mathematically, what's going to happen is that when you're subtracting a negative number, it's the same as an addition. So 92 minus -1 is the same thing as saying 92 plus 1. So our new atomic number is 93 for the beta decay of uranium-235. And similarly, in gamma decay, we can write this same process. In gamma decay, uranium began with 92 protons in the center of its nucleus, and we lost none of them in gamma decay. So our number is still 92 for our atomic number. So nothing changes in gamma decay because gamma decay is just pure energy and light is often in the form of waves. So it's not necessarily a particle, okay? So look at these 3, and the next step, all you have to do now is we're gonna figure out what our element is, of our daughter element, and what its symbol is, who's in the periodic table. So what I've written for each of these is the element box for each element whose atomic number matches the daughter element that you see on your screen. Based on that information that we found on our periodic tables, we match those atomic numbers just like I said, so now we know the chemical symbols for each of those. TH for thorium, NP for neptunium, and U for uranium. Notice that in gamma decay, it's just pure energy, so the element doesn't change at all. Also notice that the mass numbers for each of these do not match. So in thorium, we have a mass number of 231, and what you see on our periodic table is actually a mass of 232. Don't use that number. Use what we have from our decay because these are isotopes most likely of the elements you're going to see on the periodic table. Sometimes they will match, but very rarely. So use the numbers that you're getting from your math across the top. And that's all. Hopefully this helps clarify alpha, beta, and gamma decay, and you can see the thought process behind each step. Have a great day, and thanks for sitting in for another lesson with Mrs. Fox.